Assalamualaikum and hi everyone! Today, our group will be presenting about RFID technology for our video presentation. Before we start, let me introduce to you our team members. For our team, we consist of 4 members. First, Aish Iskandar. Second, Nurin Zukrina Husna. Third, Nora Shika. And fourth, it is me, Wan Nasrin. So, let's start our presentation. So let's start with introduction. First of all, let me explain to you what RFID technology. RFID stands for Radio Frequency Identification. RFID technology is a modern technology that is used for automatic identification of objects. Unlike manual identification methods, RFID allows objects to be identified quickly and accurately without human involvement. And from this case, it can reduce human error as much as possible. Each item is attached with an RFID tag that stores data such as a serial number or a product information, which can be detected by an RFID reader. RFID uses electromagnetic waves, which are created when electric and magnetic field oscillate together. And this is why RFID is related to physics. The interaction between the oscillating electric and magnetic field enable wireless communication over short or a long distance depending on the system design. A changing magnetic field can induce an electric current in a nearby conductor, and thus is a physics principle. This is based on the Faraday's law of electromagnetic induction. For the more explanation about the Faraday's law, my friends will be explain it to you later. It provides power to the passive RFID tags, so they do not need a battery. Passive RFID tags do not have an internal power source. Instead, they rely on the energy transmitted by the reader's electromagnetic field. When the tag absorbs this energy, it becomes powered temporarily and is able to transmit its stored data. This makes passive tag cheaper, smaller, and a long-lasting compared to active tags which contain battery. RFID tags can be read without direct contact under barcode. And lastly, RFID does not require line of sight scanning. This means the reader can detect tags even if they are inside the box, behind the object, or at some distance. Barcodes, on the other hand, must be visible and aligned with the scanner. I think that's it for introduction. Let us continue with electricity and magnetism concept.
RFID technology works on the principle of electromagnetism, where wireless energy and information are transferred between a reader and a tag. So in this case, we will have two concepts, which are Faraday's law and electromagnetic wave. I will start by explaining the Faraday's law. Faraday's law states that a changing magnetic field can induce an electrical voltage in a conductor, such as a coil. In RFID technology, the reader generates an electromagnetic field and sends it back to the tag. Then the tag's antenna that is designed as a small coil of a wire will receive the changing magnetic field. As a result, it causes the antenna to generate an induced voltage even though the tag does not have any battery. This induced voltage provides enough power to activate the microchip inside the passive tag. Once powered, the tag can process and send its stored data back to the reader. The amount of voltage induced depends on factors such as the distance between the reader and the tag, the strength of the electromagnetic field, and the antenna design. So moving on to electromagnetic wave, electromagnetism is the key to how RFID works. The RFID reader produces an alternating electromagnetic field to send energy and signals. When a passive tag enters this field, it absorbs the energy to power its microchip. Once activated, the tag sends information back to the reader by changing how much electromagnetic energy it reflects by a process called backscatter modulation. Different frequencies also affect on how well this communication works. For low frequency, they rely more on magnetic coupling like a transformer, while high frequency use radio wave propagation. Because of this, the field strength and frequency determine the tag's reading range, speed, and overall performance. In short, electromagnetism allows the RFID reader and tag to communicate wirelessly without physical contact or any battery.
Here are three different technologies that apply electricity and magnetism. The first one is fingerprint scanners. It detects unique ridges and valleys of a fingerprint using electric field. The second one is electromagnetic locks. It generates a magnetic field through electric current to keep doors securely closed and only release them when access is authorized. The third one is airport scanners, which monitor changes in magnetic field to detect metal objects. So when metal passes through, it triggers alerts for security personnel. Now, let's look at the benefits of this system. First, they provide more in-depth management information by capturing real-time data, which helps managers to plan better operations and operate operations more effectively. Second, they improve inventory management by ensuring accurate stock label and also reducing human errors. The third one is they shorten processes. By streamlining workflows, it improves overall efficiency. Let's consider some of the challenges these systems may face. Software and configuration problems can occur when incorrect settings override label placements or system parameters, causing errors that disrupt operation. Hardware and tech damages such as cracks, bending, and scratches can prevent devices from functioning properly. Finally, environmental limitations, including extreme temperatures, liquids, or the presence of metal, can affect the system performance. Being aware of these challenges is important to ensure that systems work reliably and deliver their intended benefit.
Hi, my name is Aish Iskandar, and for my part of the presentation, I will explain three future development and three key innovation of RFID technology, especially in the field of security and access control. Three future development. Firstly, RFID technology will have stronger security and encryption. Future system will use advanced protection to prevent cloning, hacking, and unauthorized access. This makes RFID much safer for high security environments. Secondly, RFID will be integrated with biometric systems such as fingerprint or facial recognition. By combining RFID with biometric, identity verification become more accurate and reduce the chance of impersonation. Third, RFID tags will become smaller, thinner, and more flexible. These miniaturized tags can be embedded into clothing, wearable, or devices, making the access process smoother and more seamless. Next is three innovation for RFID technology. The first innovation is the creation of battery-free energy and harvesting RFID tags. These tags can power themselves using radio wave or light, which reduce maintenance and improve convenience. The second innovation is hybrid RFID tags, which combine NFC and UHF in one tag, more flexibility to different security levels. The third innovation is the use of blockchain technology to secure RFID data. Blockchain makes access record more trustworthy by preventing any form of data tampering. In conclusion, this future development and innovation show that RFID technology will continue to evolve, becoming more secure, more intelligent, and more efficient for modern access control systems.
Lastly, for conclusion, RFID shows how physics concepts such as electric field, magnetic field, and induced current can be applied in a practical technologies. And RFID relates with the physics principle, which is the Faraday's law and also electromagnetic wave. It is enables simple, wireless, and efficient identification in the modern world. Like I said for introductions, RFID technology can reduce human error as much as possible by automating data collecting processes. For example, after RFID text has been scanned, the data will go automatically to the data collecting apps that we use in our devices. RFID technology also widely used in a real-world application, especially in our country, Malaysia. It is being used in retail, transportation, healthcare, and security. RFID technology also shows strong potential for future development and expansion due to its reliability and adaptability. I think that's it for the conclusion and that's it for our presentation. This is some reference that our team member used to complete our video presentation. And that's it. Thank you.